Hello students, Ms. Slyman here with some notes about L'Hopital's rule. You can see here that it talks about limits initially, and L'Hopital's rule is all about limits. However, something happened in the conversion to the Google Doc that you are missing the word limits. And so as we're going through these notes, I'm going to be giving you the correct version. Your correct version is also in our Google Drive folder, and I'm sorry that it didn't print for you. But your first one to fix is adding in the limit as x goes to infinity in question 4 here. So let's go through this introduction. So we've looked at limits back in Unit 1, and now we're going to look at them again and combine them with our derivatives. So let's think about how those could be connected. So we've got the function f of x equals x squared. That's a good known function for us. It looks like this. And as what's happening to the y values as x is approaching infinity? Well, that's my limit as x goes to infinity of x squared. So x squared are my y values, and we know that that's going to infinity. Well, for ln of x has a vertical asymptote at the y-axis at x equals 0, and then it goes up. It goes through the point 1, 0, and then it continues to grow, but it grows really slowly. So this one is x squared, this one is ln of x. So again, limit as x goes to infinity, this time of ln of x, but it's also infinity. However, f of x is growing at a much faster rate as long as we're looking out towards infinity. And I know that because looking at my slope values, they're much greater out in this area. In this area, that's not true. Between 0 and 1, this function is definitely growing at a faster rate. But as x goes to infinity, f prime of x is consistently greater than g prime of x. So now evaluating the limit, well, if I just tried to evaluate the limit using direct substitution of ln of x over x squared, well, I would get infinity over infinity. So evaluating them separately gives me infinity over infinity. This is what we call indeterminate. So it can't be determined because I don't know what infinity divided by infinity is. However, knowing this, that this is growing so much faster than this, we know that x squared is the dominant function. So I'm going to have a small value divided by a much bigger value. So using logic, I know that as x goes to infinity, ln of x divided by x squared must be approaching 0. Because super big number divided by super small number, or much smaller number, is going to be 0. So this is our introduction to thinking about L'Hopital's rule. We'll get into what the rule actually is in the next video.